In June 1941, when the first German divisions crossed the Soviet border during Operation Barbarossa, Wehrmacht soldiers expected to face an army equipped with outdated bolt-action rifles, a military force they considered technologically inferior. What they encountered in the initial weeks of combat left them perplexed and alarmed. Letters sent home by German soldiers described the shock of facing Soviet troops armed with semi-automatic rifles, allowing for a higher rate of fire and greater combat efficiency. This weapon was the SVT-40, a semi-automatic rifle that would challenge German military doctrine and influence the development of infantry weapons in the years to come. The German High Command had built their entire Eastern Front strategy on the assumption of technological and industrial superiority. Their intelligence reports consistently underestimated Soviet manufacturing capabilities, painting a picture of a backward nation incapable of mass-producing sophisticated weaponry. Yet here, in the hands of Red Army soldiers, was proof that this assumption was dangerously flawed. The SVT-40 represented more than just a weapon. It was a symbol of Soviet industrial might that would force a complete re-evaluation of enemy capabilities. The story of the SVT-40 begins in the late 1930s, when Soviet military planners recognized the need for a rifle that could bridge the gap between individual marksmanship and squad-level firepower. Fedor Vasilyevich Tokarev, already renowned for his TT-33 pistol design, was tasked with creating a semi-automatic rifle that could give Soviet infantry a decisive advantage. His challenge was immense: develop a weapon that combined the accuracy of a sniper rifle with the rapid-fire capability of a submachine gun, all while maintaining the reliability needed for mass production and harsh battlefield conditions. Tokarev's design philosophy centered on simplicity and effectiveness. The SVT-40 featured a gas-operated mechanism that diverted propellant gases to cycle the action automatically, eliminating the need for manual bolt operation between shots. This system allowed a trained soldier to fire aimed shots at a rate of 20-25 rounds per minute, compared to the 10 to 15 rounds achievable with bolt-action rifles. The rifle's 10-round detachable magazine could be quickly replaced, maintaining sustained fire during critical moments. At 48.3 inches in total length and weighing 8.5 pounds unloaded, the SVT-40 was remarkably well-balanced for its capabilities. The technical specifications revealed the weapon's advanced engineering. The 24.6-inch barrel was precisely rifled to stabilize the 7.62 cal 54mm cartridge, providing effective range up to 1,640 feet with iron sights. The muzzle brake reduced felt recoil by approximately 30%, allowing for faster follow-up shots and improved accuracy during rapid fire. Perhaps most importantly, the rifle incorporated a gas regulator that could be adjusted for different ammunition types and environmental conditions, ensuring reliable operation from the Arctic tundra to the Central Asian deserts. The first combat trials of the SVT-40 occurred during the Winter War against Finland in 1939-1940, where Soviet forces encountered unexpected resistance from well-trained Finnish troops. Finnish soldiers, armed primarily with bolt-action Mosin Nagant rifles, initially held significant advantages in marksmanship and forest warfare tactics. However, when Soviet units equipped with SVT-40s engaged Finnish positions, the dynamics shifted dramatically. Finnish veteran Simo Haiha, later known as the White Death, noted in his memoirs the psychological impact of facing Soviet soldiers who could deliver rapid, accurate fire without the telltale pause of bolt manipulation. The rifle's performance in sub-zero temperatures proved exceptional. While many automatic weapons of the era suffered from frozen mechanisms and unreliable cycling, the SVT-40's robust gas system continued functioning in temperatures as low as 40 degrees Celsius. Soviet reports documented instances where Finnish positions, accustomed to the rhythmic single shots of bolt-action rifles, were overwhelmed by the sustained fire from SVT-40-equipped squads. The weapon's effectiveness was so pronounced that captured SVT-40s became highly prized among Finnish forces, with some units specifically targeting Soviet soldiers carrying the distinctive rifle. Production challenges initially limited the SVT-40's deployment. The rifle required precision machining and high-quality steel, resources that were in short supply as the Soviet Union prepared for larger conflicts. However, by early 1941, production had ramped up significantly. The Tula Arms plant alone was producing over 1,000 SVT-40s per day, with additional manufacturing facilities in Izhevsk contributing to the growing arsenal. This industrial achievement represented a remarkable transformation for a nation that, just 2 decades earlier, had been primarily agricultural. When Operation Barbarossa commenced on June 22, 1941, German forces advanced with confidence, born from their rapid victories in Poland, France, and the Low Countries. Wehrmacht doctrine emphasized speed, coordination, and the superiority of German engineering and training. Infantry tactics relied heavily on the proven Karabiner 98K bolt-action rifle, supported by machine gun teams and artillery. German soldiers had trained extensively against opponents using similar bolt-action weapons, developing tactics that exploited the natural pauses in enemy fire when soldiers worked their rifle bolts. The first encounters with SVT-40-equipped Soviet units shattered these tactical assumptions. Obergefreiter Hans Müller of the 6th Army wrote to his family, "The Russians have rifles that fire like machine guns, but with the accuracy of our best marksmen. We advance expecting the usual pause after their shots, but the bullets keep coming." This sentiment was echoed across the Eastern Front as German units discovered that their carefully rehearsed tactics were suddenly obsolete. The psychological impact extended beyond individual encounters. German intelligence officers, analyzing captured equipment and interrogating prisoners, began to realize the scope of Soviet industrial capabilities. The SVT-40 was not a prototype or limited production weapon. It was being manufactured in quantities that suggested a level of industrial sophistication that contradicted all previous assessments. Wehrmacht reports from August 1941 noted that entire Soviet rifle companies were equipped with semi-automatic weapons, a deployment scale that no other army in the world had achieved. The technical superiority of the SVT-40 became apparent in specific combat scenarios that highlighted the weapon's advantages. During the Battle of Smolensk in July 1941, German forces encountered Soviet defensive positions where traditional assault tactics proved costly and ineffective. Lieutenant Friedrich Weber documented an attack on a Soviet-held village where his company expected to suppress enemy riflemen with coordinated rushes between their shots. Instead, they faced continuous fire that pinned down entire squads and forced costly flanking maneuvers. The rifle's accuracy at extended ranges particularly impressed German marksmen. Captured SVT-40s were extensively tested by Wehrmacht ordnance specialists, who found that the weapon could consistently hit man-sized targets at ranges exceeding 1,300 feet. This performance matched or exceeded that of the German Karabiner 98K, while providing the additional advantage of rapid follow-up shots. German snipers who acquired SVT-40s often preferred them to their standard-issue rifles for situations requiring multiple quick engagements. Soviet tactics evolved to maximize the SVT-40's capabilities. Red Army training manuals emphasized the concept of continuous fire superiority, where squads armed with semi-automatic rifles could maintain suppressive fire while maneuvering. This represented a fundamental shift from traditional rifle tactics, which relied on coordinated volleys followed by movement during reload periods. The SVT-40 allowed Soviet infantry to maintain pressure on German positions while simultaneously advancing or repositioning, creating tactical flexibility that German commanders struggled to counter. The industrial implications of widespread SVT-40 production forced German leadership to confront uncomfortable truths about Soviet capabilities. Intelligence estimates had consistently portrayed the Soviet Union as industrially backward, capable of producing large quantities of simple weapons, but lacking the precision manufacturing required for sophisticated equipment. The SVT-40's complex gas system, precision-machined components, and reliable performance under combat conditions demonstrated manufacturing capabilities that rivaled those of established industrial powers. German ordnance experts who examined captured SVT-40s were particularly impressed by the quality of metallurgy and machining. The rifle's barrel showed evidence of advanced steel treatment processes, while the gas system components demonstrated precision tolerances that required sophisticated manufacturing equipment. These observations prompted urgent reassessments of Soviet industrial capacity and led to revised intelligence estimates that painted a far more formidable picture of Soviet war production potential. The economic implications were equally significant. Each SVT-40 represented a substantial investment in materials, machinery, and skilled labor. The fact that the Soviet Union could produce these weapons in large quantities while simultaneously expanding tank and aircraft production suggested an industrial base far more robust than previously believed. German economic analysts calculated that SVT-40 production alone required steel allocation equivalent to several hundred medium tanks, yet Soviet forces continued to field both weapons in increasing numbers. As the war progressed, the SVT-40's influence on German weapon development became increasingly apparent. The Wehrmacht's urgent need for semi-automatic rifles led to accelerated development programs for weapons like the Gewehr 43, which borrowed heavily from SVT-40 design principles. German engineers studied captured SVT-40s extensively, reverse engineering key components and adapting successful features for their own weapons. This technological transfer represented a remarkable reversal of expectations, with German designers learning from Soviet innovations. The psychological impact on German soldiers extended beyond individual encounters to broader questions about enemy capabilities and war objectives. Feldwebel Klaus Richter wrote in his diary, "We were told we were fighting primitive peasants with obsolete equipment, yet they have rifles more advanced than ours, and they know how to use them." This sentiment reflected a growing awareness among German troops that their initial assumptions about Soviet military capabilities were fundamentally flawed. Soviet propaganda effectively exploited the SVT-40's success, using the weapon as a symbol of technological achievement and industrial might. Red Army newspapers featured stories of soldiers using SVT-40s to defeat German attacks, while factory workers were praised for their role in producing the rifle that stopped the Wehrmacht. This narrative served both to boost domestic morale and to signal to international observers that the Soviet Union possessed sophisticated military technology. The SVT-40's performance in urban combat revealed additional advantages that further challenged German tactical doctrine. During the Battle of Stalingrad, Soviet defenders armed with SVT-40s proved particularly effective in the close-quarters fighting that characterized the city's destruction. The rifle's semi-automatic capability allowed defenders to engage multiple targets quickly, while moving between defensive positions, tactics that proved devastatingly effective against German assault teams trained for more conventional warfare. German after-action reports from Stalingrad consistently noted the difficulty of suppressing Soviet positions defended by soldiers with semi-automatic rifles. Traditional tactics of fire and movement, which relied on predictable pauses in enemy fire, became suicidal when facing opponents who could maintain continuous aimed fire. This forced German units to develop new assault techniques, often requiring additional support weapons and longer preparation times that slowed the pace of urban operations. The rifle's reliability in the harsh conditions of Stalingrad impressed even German soldiers who had initially dismissed Soviet equipment as inferior. Dust, debris, and extreme temperature variations that rendered many weapons unreliable had minimal impact on the SVT-40's performance. Captured weapons continued functioning effectively even after extended periods without maintenance, a testament to the robust engineering that characterized Tokarev's design philosophy. By 1943, the cumulative impact of the SVT-40 on German military thinking had prompted fundamental changes in Wehrmacht doctrine and equipment priorities. The urgent need for semi-automatic rifles led to increased production of the Gewehr 43, while training programs were modified to address the tactical challenges posed by enemies armed with rapid-fire weapons. These adaptations represented a significant shift in German military philosophy, acknowledging that technological superiority could no longer be assumed. The strategic implications extended beyond individual weapon systems to broader questions about industrial capacity and technological development. German intelligence services revised their assessments of Soviet capabilities across multiple domains, recognizing that the nation they had dismissed as backward was capable of sophisticated engineering and mass production. This realization influenced German strategy in areas ranging from aircraft development to tank design, as planners acknowledged they were facing a more formidable opponent than initially believed. The SVT-40's success also influenced Allied perceptions of Soviet capabilities. British and American military observers, initially skeptical of Soviet claims about their weapons technology, began to reassess their evaluations after examining captured German reports and interviewing prisoners who had faced SVT-40-equipped units. This shift in perception contributed to growing Allied confidence in Soviet ability to sustain prolonged resistance against German forces. The production challenges that initially limited SVT-40 deployment were gradually overcome through innovations in manufacturing processes and worker training. Soviet factories developed specialized tooling that reduced the precision machining requirements, while training programs created a skilled workforce capable of maintaining quality standards under wartime pressures. These achievements represented a remarkable transformation of Soviet industrial capabilities, demonstrating the nation's ability to adapt and innovate under extreme circumstances. Quality control measures ensured that SVT-40s maintained their performance standards even as production volumes increased. Each rifle underwent extensive testing before leaving the factory, with acceptance standards that exceeded those of many contemporary weapons. This commitment to quality reflected Soviet understanding that the rifle's reputation for reliability was crucial to its tactical effectiveness and psychological impact on enemy forces. The economic efficiency of SVT-40 production improved significantly as manufacturing processes matured. By 1943, the cost per rifle had decreased by approximately 40% compared to initial production runs, while quality metrics showed consistent improvement. This achievement demonstrated Soviet ability to achieve both quantity and quality in weapons production, capabilities that would prove crucial in the prolonged conflict with Germany. As the war entered its final phases, the SVT-40's legacy extended far beyond its immediate tactical impact. The weapon had fundamentally altered German perceptions of Soviet technological capabilities, forcing acknowledgement that their enemy possessed sophisticated engineering and manufacturing abilities. This recognition influenced post-war assessments of Soviet potential and contributed to the strategic calculations that would shape the emerging Cold War. The rifle's influence on weapon development continued long after the war's end. Design principles pioneered in the SVT-40 influenced the development of assault rifles and battle rifles in multiple nations, while manufacturing techniques developed for its production informed post-war industrial practices. The weapon's success demonstrated that technological innovation could emerge from unexpected sources and challenge established assumptions about national capabilities. Today, when we examine the SVT-40 in museums or private collections, we see more than a military relic. We see tangible evidence of how technological innovation can emerge from unexpected sources and challenge entrenched assumptions about national superiority. Stalin's rifle not only changed the battlefield, it changed the way the world viewed Soviet technological capability, a transformation of perception that would echo through the Cold War and beyond.